speaker in this morning's session is Dr. Serena Bonaretti. She is a founder and research scientist at Transparent Musculoskeletal Research, whose aims are to do and to promote open and reproducible research, mainly but not only in musculoskeletal imaging. Serena is collaborating with universities and industry in open data management projects and in order to develop new and open reproducible workflows. She is leading the creation of the Jupyter community in musculoskeletal imaging, and she has recently started a YouTube channel where she teaches how to practically perform open reproducible research. And her talk title today is Why We Should Use Jupyter Notebooks in Medical Imaging Analysis. And so with this, I'll pass the baton to Serena.
Thank you, everybody, for being here on this Saturday morning, and thank you very much to the organizers of this workshop. I'm really very happy to be here, and I will try to do my best to explain and see and share my opinion on why we should use Jupyter notebooks in medical image analysis. When I discussed with Vittorio, one of the organizers of the workshop, he really invited me to share my experience with Jupyter Notebook. And so here is my story to start. So it was more or less the middle of 2017, and I was at the Department of Radiology of Stanford University back then, and I was given this task to segment and analyze some knee images, which is a pretty common task in the musculoskeletal imaging community. And this came out because my group was collaborating with scientists that were interested in analyzing knee images, but they had limited experience in medical imaging. And specifically what they wanted was some code to extract the measures of osteoarthritis progression. Osteoarthritis is one of the most common diseases of the musculoskeletal system that we analyze and work on. And specifically, they wanted the femoral cartilage thickness and the relaxation times related to the cartilage, which in my mind simply meant that, first of all, I had to segment the images in order to derive these measures. So I said, okay, no problem. I'm part of this community. I know how these things go. And so I started to do some literature research. I found very good literature reviews, and I came up with at least 29 algorithms that were already published around. And I grouped them in active contours, atlas-based, deep learning, graph-based, etc. And I said, okay, I can use one of these ones because anyways, the core of the scope of the project was not to create a new algorithm, right, but to create some code that other researchers could use. And the surprise was that out of these 29 algorithms, only 2 implementations were actually open source. And this was quite a surprise, but not only. The problem was that one of these algorithms, one of these implementations was without documentation. So for me, it was basically impossible to understand what was going on. The other one had good documentation, but it was written in C++. And for me, that is pretty hard to grasp. So I said, okay, I have any ways to do something. And so what should I do? As I said, I was not interested in creating another algorithm because there were already 29 around. I didn't want to come up with the 30th. And I needed, again, to create a pipeline that would pre-process, segment, and analyze knee images. So by using already existing algorithms, and my focus was to put the pieces together, the whole pipeline together, and make it easy for these people to work. So I didn't really know how to start, but somehow I started, of course. And initially, I wanted to use MATLAB because this is what I know, and this is what I knew actually back then, and I already had some code around. But very soon, I realized that MATLAB is actually not open source. And so as silly as it might sound, actually not everybody has a MATLAB license. And I did not want to write new closed source code and be the 28th after the other 27th in the literature. So I started in C++, and where I could, that I knew a little bit from my PhD, and there I could use some open source libraries, for example, ITK and Elastics for image registration in order to do atlas-based segmentation. But there were a couple of buts here again. The first one was that I had to create the executable in Windows because my colleagues were working in Windows, but I am working on a Mac. And so I already had a technical difficulty right there. And the second thing is that the command lines are not ideal for people with limited coding, because they always look overcomplicated. And coding in C++, as I said before, was actually not exactly a piece of cake for me. And finally, the pipeline would have still resulted fragmented, because on one side I had anyways the code, and then my collaborators had to open a visualization software like ITK Snap or Slider or anything, Slicer, sorry, anything, and so the pipeline was still kind of fragmented. But anyways, I starting at the same time, I was still looking for a better solution until a colleague of mine, a statistician, showed me that in the statistics community, they were using something that was the R Markdown. That was this web application-based format where they could create reproducible workflows, where they integrated code, text, graphs, etc., everything in one place. And I thought that this was a wonderful solution. This was exactly the solution I needed for my own topic as well. So he said, yeah, look, there is something similar in Python. They have developed this for like 2 years or so. It's something new that is getting more and more popular. Try to look at that. It's called the Jupyter Notebook. And this is why I actually started to fall in love really with the Jupyter Notebook. Just out of curiosity, if you do not know where the name comes from, actually it comes from Julia, Python, and R, which are the 3 core programming languages mainly supported by Jupyter. Just to make sure that everybody knows exactly what I'm talking about, I know that everybody at this point knows what a Jupyter Notebook is, but just to make really sure, just a quick pause on this story. So a Jupyter Notebook is a web-based application that integrates narrative, so we can write text where we explain what we are doing. We can write the equations we are using. We can have some figures where, for example, we explain the pipeline we are creating and so on. There is a live coding that supports several kernels or several programming languages like Python, C++, R, etc. And also we can visualize our results. For example, it can be graphs, it can be image rendering, 3D rendering as well, and so on. In addition, it definitely favors the reproducibility of computation because we can rerun the Jupyter Notebook several times and hopefully always get the same results. It is convenient to share among researchers, and it's very easy to integrate in our publications. Finally, there are some very practical technical advantages that works for all the operating systems. So we don't have to build code differently for the different operating system, and we can run it on a cluster, we can run it locally. It's really extremely versatile. So when I discovered of all this, I really wanted to try it out. And so how did I start? Well, I realized that I had to learn, first of all, Jupyter and all its environment. Then I had to learn Python. And then I had to learn the Python packages, which took me actually a while to identify as well, which ones I had to use. But then I realized that the NumPy was the one for linear algebra, Matplotlib was the one for graphs, and Simple ITK was the one to handle medical imaging. And so, images, sorry. And so I started actually a bit randomly collecting the information I found online. And I realized that actually YouTube is a great source of information. I really found a huge amount of material, people coding, conference tutorials that really helped me to get on track very, very quickly. There are around also a lot of blogs, and there are also several websites with live coding, where they give you a small task, you write the code, and then they correct you automatically. So this is the way I got started. But I still had to implement a whole workflow, right? That was still divided in the same three parts: pre-processing, segmentation, and analysis. So how did I jump into that? Actually, I think really that it took me just 2 weeks to really get started. And the way I did it, and for me was very successful, was that I started translating the code I already had. As I've told you, I had some code in MATLAB, some code in C++, that where I was trying out things, and by translating this code into Python allowed me to focus on the language, on the syntax of Python, and not on the algorithms. And so I could learn incrementally first the language and then the algorithms. And the second thing that I learned was that when I had any problem, I didn't really need to spend a huge amount of time on there, because the power, but mainly the extension, the dimension of the Jupyter Python community is huge. There is always everybody who has already had the same issue that I have. And so I just look online and I always find solutions on blogs, Stack Overflow, etc. So I got started, I started implementing it, and then step by step, this is the way I created Pioneer. Pioneer, that it is an image analysis workflow specifically designed for open and reproducible research on femoral knee cartilage. And it is composed by the famous 3 parts that I've mentioned a couple of times at this point. So first, there is a module, a notebook for pre-processing, where I pre-process the images both spacing and intensity. Then I do the segmentation, which right now it's a very simple single atlas segmentation, nothing too fancy. And then there is the analysis, both the morphology and the relaxometry. Each of these parts uses 1 or 2, depending on the task, 1 or 2 Jupyter Notebook as a user interface. And basically, it works a little bit like this. This is, for example, a summary of the Jupyter Notebook that I use for the relaxometry in the analysis part. And I put here just an extract because it's a bit too long to make a proper visualization for a presentation. But as you see, from loading the data to going through the whole computations and to the visualization, all my workflow for the relaxometry part is in here. I don't have anything else to run the relaxometry. Behind the different notebooks that correspond to each of the parts of the pipeline, there is the actual Python package called Pioneer that is divided in modules, so that I can plug in the functions in the notebooks outside exactly the way I need it. And it contains, of course, the core functions that run the machine behind all this. And so the user potentially just has to input here their own images and then run the code, and everything works. One thing that I think it's important for this workshop about Pioneer is to share how I structured the notebooks that are structured in the same way across the different parts. And so at the beginning of each notebook, I have the link to a GitHub repository, to the GitHub repository of Pioneer. And then the second link is actually to the documentation of Pioneer, and specifically to the page related to that explains how to use the notebook as well. Then there is always an introduction that says what's going to happen, what the aim of the notebook, and what are the computations that are going to happen. Then there is the user input that in the majority of the cases is just a TXT file where the input just lists the images that are going to be processed. In this case, it's just a bunch of DICOM folders. And then there is the body of the notebook. So there are the commands, as you see here, alternated or explained by the narrative. I have different levels of subtitles, the text itself, and the introduction, and they introduce each command of the code. And then at the end, when I get the results, I have the visualizations that are mainly of two types, depending on the notebook. But there are qualitative visualizations, and basically they are to have a quick and dirty idea to see if actually it works, if the segmentation worked, for example. So I print out a slice with the segmentation mask, or this is for the thickness, and this is for the relaxometry. But then I also have quantitative visualizations with the graphs and tables with actual numerical results that also have the numbers. And then actually I save these things on file and then use them later to compare, for example, methodologies or so. Finally, I reference to the algorithms, when they are not mine, of course, included in the notebook. And as very last step, I always write the dependencies. Dependencies are something very, very simple, but very, very important. I use this package called the watermark, and basically I print out the version of IPython or Jupyter Notebook, whatever you want to call it, of the versions of the packages, Python packages that I'm using, and of my machine. And this is important for the reproducibility of the computational environment. I wanted to make sure that maybe in 3 or 4 years, when all these packages and machines will be different, if I have any issue with running my Jupyter Notebook, I know which kind of versions of the libraries I use, and so I can enforce the installation of these libraries and still use my Jupyter Notebook and keep my notebook reproducible across the years. This is what I think is important about Pioneer for this conference, for this workshop, and I presented this at conferences, and people were happy about this, and I started to contact some colleagues. There was a proposal last December to build the Jupyter community to a workshop, and I contacted some colleagues, and we applied, and we actually magically and very happily got the grant. And so basically the aim is to start building the Jupyter community in musculoskeletal imaging. We were supposed to have a workshop actually this past week here in Maastricht, but of course it didn't work out. So we had the very first online kickoff meeting on Tuesday. That was supposed to be the first day of the workshop, and it was a very exciting moment. We were about 16 spanning across the globe, from the west coast of the United States, UCSF, then Denver, Calgary, North Carolina, ITK, Kitware, and then Europe, Leuven, Lund in Sweden, Rizzoli in Bologna, myself, and then we ended up to Melbourne. And it was really interesting to see how my colleagues and friends are actually enthusiastic and determined about growing, creating a common platform. And in fact, the aim of our community will be to create open and reproducible workflows by combining the existing code that we already have around as a first step, so that we can overcome the fragmentation of the code that we have around as a community. And we hope then to create, in this way, to create a solid base on which we will be able to create new code thanks to some structure guidelines that we are going to give ourselves. So at this point, you can tell me, okay, Serena, thank you for sharing. This is a very nice story, but you know, I need to open my laptop and where do I start? What do I do? So I allowed myself to put together some practical tips that I've learned across these last 2.5 years using a Jupyter Notebook intensively together with Python. And so I would like to share them with you, hoping that they will be useful. The first thing is if you are an absolute beginner, so you roughly know what a Jupyter Notebook is, I would recommend you this material that I divided in video tutorials. The first one is a playlist that I actually made myself. It might be not technically very sophisticated, but I think the content is actually interesting. And where I explain Jupyter Notebook and Python specifically for scientists. And I came up with this idea that seems to work of conceiving the Jupyter environment as a Russian doll where the different parts are nested into each other. Jupyter Lab is the web-based environment in which you can find a lot of things, among which Jupyter Notebook. In Jupyter Notebook, you can use several languages, among which Python. And then in Python, you have a lot of packages, among which for scientific purposes, mainly we look into NumPy, Matplotlib, Pandas, Simple ITK if we do medical imaging, and Keras if we do deep learning. The other videos that I highly recommended are the tutorials that happen during the SciPy and the PyData conferences. Among the conference talks, you can find tutorials that last maybe 3 hours and that are linked to GitHub repositories with the notebooks where they actually teach us how to do things. There are tutorials about Jupyter Lab, about NumPy, about Pandas, and so on. So they are a very good starting point. If you prefer instead to have more hands-on material, I highly recommend the Simple ITK notebooks that are very well made, and they really guide us through the use of Simple ITK for medical images, from reading and writing an image into using filters, visualizing images, and so on. And then there are a bunch of other tutorials here. I will share the link to my presentation. It's already on Zenodo. And finally, some examples specific for medical image analysis. Also, the hands-on tutorials actually are specific for medical image analysis. I would highly recommend NiPipe for the neuroscience community, and I guess many of you already know it. And then Pioneer, if you wanted to have a look at what I've done as well. And there is also this deep learning toolkit. So I just recommend you to start, and then starting from that, learn. And once you're ready to, it's not going to take you a lot, maybe like 2 weeks or so. And then when it's time to start your own project, what to do? Well, first of all, of course, open a notebook. And at this point, you will know how to do it, or you already know how to do it. The first thing I always do is actually to write the narrative, at least the titles and the subtitles, because this is a way to provide an outline to what I'm going to do. After writing the narrative, I start with the code. And the code is that has to be, can be very simple at the beginning and gets more and more complex as I go, of course. And the most important thing, especially for beginners, is to always keep in mind to run the cells in sequence. It can happen that you change a variable in a cell above and you forget to run the cell, and then your result in the cell below does not change and you get confused. So if these numbers get weird and you don't know exactly what to do, just restart the kernel, which means restart the notebook from scratch, and you will be able to restart, and the flow will restart again. when you will, when your code will start to become more complex and you will start to have functions inside your notebooks, one way, and maybe you will need the same function across different notebooks, consider moving the functions to a Python module. Python modules are just files, text files that have an extension .py, where you can put your functions, and then in the notebook you import the module like you would do with any package, and then you call the function, and this way you start creating and building up your material. And of course, at a later stage, you can combine the modules into packages and so on. And then what is important in this process is to always remember to keep the notebook human readable, both for ourselves and if I can say a bit in a selfish way, mainly for ourselves, because I myself get very mad at myself when I look at code that I wrote maybe 6 months before or 3 months before or before vacation, and I don't remember what I was doing. So the first thing is to keep it always human readable for ourselves and for the others, because notebooks are made to be shared. So the first thing that we always want to do is to organize the narrative properly. As I mentioned before, we have a title of the notebook, we have the paragraphs that are the units of work, where we have titles, subtitles, and always we introduce what the code is going to do, the code coming up, and then if we get interesting results, or depending, like if this is if it is the case, it's always nice to comment the result that we obtain. And then we also wanted to keep the code organized. So we put all the package imports at the very top, and then the functions, and then the variables, or if you prefer, first the variables and then the functions, but to be consistent. And then we have the workflow body, and then again, the dependencies, which will allow us and the others to reproduce our workflow. Once we are at this point, it's already very, very good. I think we can be already super happy with what we have done. We can, however, do a last mile and make our notebook even more reproducible. The first thing, and this is mainly for when we share it with other people, the first thing is to automatically download the data from a repository. So at the beginning of the notebook, when you loaded the data, if your data is on a repository like Zenodo, for example, directly download it so that people do not need to look for data separately, but they really just run the notebook and it downloads the data as well. The second thing is to always automate that data manipulation. If you crop some images, don't do it manually, do it in the notebook, because otherwise it is very hard to go back from the derived data to the original data. We should define seed grants where when we use random numbers, because random numbers, at least their generation is not random at all. Providing the initial seed for the number allows the notebook to be reproducible even when there is supposed to be randomness. And finally, always print dependencies. These suggestions on how to make the notebook even more reproducible come from these papers that you see here. And again, I allowed myself to create a practical tutorial that you can find on YouTube, where you can go. I show how I do it in a notebook. Again, technically, maybe not the best tutorial ever, but I think that the concepts are in there, and you can see which kind of code to use to actually do these steps. And finally, I think the wonderful thing is that we can attach the notebooks to our papers. And there are several ways to do that. We can put a link directly in the text of our paper. We can, as I did here, for example, for my Pioneer paper, put it in a table. For example, in this table that summarizes it was the table of my method and material and method paragraph. You see each column corresponds to a data set, and first I had all the parameters about the acquisition, and then I had like, okay, for which data set did I do pre-processing, segmentation, blah, blah, blah. And each of these dots, it's a link. It's actually linked to the executed corresponding notebook in my GitHub repository. So everybody who needs to compare his or her method with mine, or wants to use it or check it or whatever, rerun it, etc., just clicks on this link, and the notebook appears magically. No, it gets linked to GitHub. Another way is in the figures. When we create the figures in the results part of our paper, it is nice in the caption to put, you see here, a link to the data, that in my case was this Zenodo, to the code that goes to the Jupyter notebook where from which I calculated this graph. And so people can play with it. If they really feel like playing, they can change colors, but otherwise they can reuse it for their own data, or like test the reproducibility of my paper and so on. And then I also have, for this kind of graphs, I also have a link to the computational environment. The computational environment means basically Binder. Binder is a fantastic tool to share the notebook in a Jupyter in an executable environment. It means that by clicking that link, people can actually play with the notebook. This is harder when we deal with the when we run the workflows for medical images, because medical images are big, and the Binder and Binder provides, I think, only 2 GB of RAM. So it's really not feasible. But for graphs and so on, it is ideal. And again, if you need some practical information on how to use Binder, you have never done it before, there is another tutorial here that you can have that really shows step by step practically how to do it. So I am getting towards the end of my presentation, and I would like to catch up with the title itself of my presentation. Why should we use Jupyter Notebook in medical image analysis? I think that there are several reasons, and the 3 ones that I think are the most important, at least for myself, are that the first one, it's because Jupyter Notebooks allow us to do open and reproducible medical image analysis basically for free. We don't have to come up with new tools. We don't have to come up with new ideas. Everything is already there. It's a way of working. If we just go with the flow, go with it automatically, we work in open and reproducible way without even realizing it. Or without putting any extra effort to do that. The second is that Jupyter Notebooks allows us to create image analysis workflows that are complete. With this, I mean from loading the image to processing the images to visualize the results. Everything is in one place. And for me, this is crucial because I really hated writing code on one side and then checking the images on another. Program. It was really a tedious way, and instead like this I have everything in one place, and that's it. And the third and not the last reason is that they are easy to they make easy to integrate our workflows into our papers and to share what we do with other colleagues. With this, I thank you very much for listening to me. I am going to stop the screen share, and I am happy to reply to any questions that you might have.
You know, maybe while we're waiting, maybe I can just start off with one question, which has to do more with the community building aspect of this technical analysis work that you've done. So I understand this is medical imaging, and the Jupyter Notebooks largely run locally. But is there also, or have you considered a website where people can play around or develop expertise with prototyping on the internet? And maybe you can talk about considerations related to that.
Yeah, you mean specifically for Jupyter Notebook?
Yeah, for Jupyter Notebook, for your musculoskeletal community.
Oh, yeah. So one way I have done, for example, for my pipeline was to create a simplified version and put it on Binder. And so if one goes to the Pioneer website, there are two Binder links where somebody can, where anybody can actually run again a simplified version. I basically undersampled the images so that they can play with that, and this is one of the possibilities of using Pioneer. For the community in general, I think that there is a learning phase that is very actually easy and very short, and I provided the material, the same that I provided in this workshop, so that people can get started, and then we start building from there. From the code perspective, we are actually divided in 4 different groups. At the beginning of this community, each group tackles a specific image task, so that we also had a small task where we are focused on, and then from there we will learn together and divide it in groups and build from there.
Thank you, Serena. I'm very impressed with the pattern you've taken, how you have put together a complete story. And so sorry for the question, that's a bit of a stretch. I was wondering, let's say that you have to run a PhD course, would you make compulsory a specific course to teach how to develop or open and reproducible experiment tools? And then in that case, what kind of course would you build? What kind of knowledge would you put in such a course?
Yeah, this is a really fantastic question, because education is really one of my main passions as well. So there are different options. There are courses. So Python allows us, the nice thing of being part of this community is that Python allows us to look also at other scientific communities, because we all have the same issues and the same aims. We just have different topics somehow, right? Or fields of expertise. But for example, I can recommend all the material created by Lorena Barba. She teaches I think fluid mechanics, I might be wrong, but something like that. And she's actually the very first one who used the Jupyter notebooks for teaching. And there is also a Jupyter book on how to use Jupyter notebooks for teaching. So this is the first idea that comes up to my mind. My second idea is to look into the Data 8 course at Berkeley. It is a course for anybody at Berkeley University, independently from the background. It's not specifically a course for people who code. It's not a course for scientific people. Everybody goes to this course and learns, also, I'm saying something maybe too random now, but also, I don't know, archaeologists need to know to compute some statistics, for example, right? So the point here is that they teach Jupyter, they teach directly data science with the Jupyter notebook. So in this case, in these two examples, there is not a specific course on Jupyter notebook, but Jupyter notebook is already integrated in the main content of what they teach. If you are interested in, and I think this is very important because it becomes naturally a way of working. Instead, if one needs to push things a little bit and needs a specific course, I have seen excellent material by Fernando Perez, who is the creator of Jupyter Notebook, and he has online a course that he gave, I think, 2 or 3 years ago at Berkeley about how to do reproducible research. In case you need the links, I can send them to you in separate emails and so on if you cannot find this material. But I think that again, these are 3 examples of people who have already been doing this for quite some time in a very successful way. And so this can be an excellent starting point. And I myself think that using notebooks like this directly in the normal workflow would be really crucial, because it would be simply a new way of coding and it would be an automatic way of working. I hope I replied sufficiently to your question.
Yes, just one more thing. Would you make such a course compulsory? I mean, all courses for PhD students?
That's a hard question. Harder than the one you gave me you asked me previously. You know, for the way I work, of course, but there are other ways of working. But I think that we are going towards a way of working that is very much towards this direction. Also, funding agencies are asking more and more for open data, and they will ask more and more also for open source code. So I think that if we wanted to think about what is going to happen in 5 years, maybe yes. Maybe yes.
Okay, thank you.
Thank you.
Hello, Serena. Thank you so much for this talk. I have a question. Actually, I'm using R Markdown instead of Jupyter Notebook, and some of my analysis take too long. And do you have any strategy or recommendation for doing this kind of analysis on a notebook? Because it's easier to do this analysis in a script, but on a notebook, every time, I'm not sure if Jupyter Notebook is similar to R Markdown, but every time I need to knit the notebook to give me the final script. But so every time I need to take several weeks. What do you do for this kind of analysis?
Yeah, so for me, I run them on the cluster. I don't know if you have any cluster that you can work on, and on clusters I never really had big problems because it's really the same. You know, if I let it go for days on a cluster or locally, it doesn't really matter. Like, what I want to say is actually that on the cluster, if I let code go by itself or on a notebook, doesn't really matter, right? So this is what I do. So it's an optimization, not optimization, but it's a time problem, I think, independently. I don't think that if you run the same code but without a notebook, it goes faster. Right. So one thing, again, I think clusters are the solution. Otherwise, yeah, but again, I don't think that the notebook is the problem. I think that it's the code that takes time. Then if you plug the code in a notebook or you keep it separate, the time, I guess it's going to be more or less the same. I don't know, maybe I misunderstood your question.
Actually, yeah, I'm not thinking that the notebook is the problem.
Okay.
I'm using R Markdown and everything. You know, we have a section for code and for the text every time that I need the notebook. It gives me the final results, and then if I want to add another text, then I need to knit it again. So every time I need to wait several days for the result.
Oh, you mean if you change something?
Yes, and that's why every time, for this kind of analysis, I put the code and ask that chunk not to be executed, and I put the screenshot of the results. I'm not sure if that is the best strategy, and that's why I'm asking this question.
Okay, I understand. I think I understand. I try another answer, and then you tell me if I understood it better. By what you were telling me, what I understood is that if you change some parameters let's pretend that you have a function that has a loop. No, let's pretend that you run this function that takes days, okay? So if you change something inside this function, what I would recommend is just that you run the same function in parallel with different parameters on a cluster. And so you're like, basically you clone kind of the same function for in different batches on the cluster, and then you run them separately, and then it's the same time. You parallelize, basically. On the other side, instead, if you change something after running this function that takes a very long time, what I usually do is that I save to disk the intermediate results. Or the results of the function. So if these are images, I save the images. If these are numbers, I save them to a text file, for example. So this way, while prototyping, let's put it like this, I can, I really split my work into parts. The first part that is anyway always giving me the same, and then the second part I load. So I write to disk the results of this first part, and then I load the same these same results in the second part or in a different notebook and work on them. And then when you have your workflow completely streamed that works nicely and you're ready for publication, you can consider putting the two things together, run it once, and then attach it to your paper. Does this answer your question?
Yes, thank you so much.
Okay.
Actually, saving and loading the result is the best option, I think. Yeah, that's great.
Yeah, at least while you're working. Then for the final paper, you put everything together nicely and you attach it.
Yeah.
But when trying out, this is what I usually do.
Great, thanks.
You're welcome.